This video will look at what to do when you have variables on both sides of the equation and need to solve it. Before we get to the video, I'd love for you to do some warm-up problems to see the difference between what we've done in the past and what we're going to do today. So go ahead and practice these warm-up problems. It shouldn't take you too long. Pause the video now. And here are those answers. Make sure you go through each one and that you ended up with the same result. I had to skip a few steps in here because I was running out of room. But your answers should be the same. Let me know if you have any questions. I'm going to move on to the steps to solving equations when you have variables on both sides. According to the list, your first job is still to look if you have any parentheses or if you have a distributive property that you need to do first. The second step is to combine like terms, depending if you have them on one side, the other, or both. Next, you may need to add or subtract entire terms that contain variables in order to get all your variables on the same side. And then you would move your constants either to the left side or the right side, depending what you need to do in order to gather all your constants together. And then finally you'll multiply or divide to solve. So it seems like a big list, but really nothing is new there except the moving entire terms if you need to collect variables on one side. Let's look at example 1. You can see that I have variables on both sides. I'll leave it like this. I have a 6x over here and an 8x over there. The problem is I need to collect my terms with the variables on one side. You can either move this entire 8x over here, or you can undo and move this 6x over there. The choice is completely yours. It doesn't matter. But because most kids seem to like the variable on the left side, I'm going to move this 8x. I cannot just combine my like terms. There's this big barrier here of this equal sign. So I need to use inverse operations to move my terms. Because 8x on the right side is positive, I need to move it to the left side by subtracting 8x from both sides. The reason you're doing that is because this situation right here, this column, 8x minus 8x, eliminates that variable. And then you simplify what you've got. I've got this 6x minus 8x, and that's going to be a negative 2x. And then I'm going to write down everything else, because nothing else has changed. If you don't like doing this in this vertical format, there is a horizontal format that I've seen kids work with, and that's fine too. Come see me if you'd like to know what I'm talking about there. But now your new equation here is just a two-step equation, and your job is to add or subtract the term that's being added or subtracted. So this, negative 3 or minus 3 is the thing that's going to need to go away. So I will subtract 3 from both sides now and just finish out this problem. Here I need to undo this multiplication, so I will divide, and you're left with x equals a positive 12. Alright, so the only real new thing here was collecting terms on the same side of the equation so that you could get your variables together in order to simplify them. Here are some more examples, and I'm just going to run through them all. You're welcome to work ahead of me. Remember, the big point of this lesson today was to collect your like terms together by using inverse operations. So in letter A, I have a d on the left side and a d on the right side, and in order to get them together, I need to either move this negative 6d over here by adding it, or I can move this d over there by subtracting that. And I think I'll go that way, so then I have numbers on both sides of my equal sign, but you're certainly welcome to do it the other way. Your final answer will be the same. So because d is positive, I'm going to subtract it. These cancel, and I'm left with negative 6d minus d. It's just like you're subtracting in columns, and that is a negative 7d, and over here you have a 4. In order to finish it off, I need to undo this multiplication by dividing. I like to write my 7s in different ways. Those cancel, and you're just left with a fraction here. You can just leave it as -4/7. Letter B. I'm going to need to distribute before I do anything else. So 2 times c gives me 2c. 2 times that -6 is a -12. Now I need to collect my terms on the same side, my like terms on the same side. So for this one, I'm going to move this 2c over there, just because I haven't done it yet, and for no other reason than that. So in order to undo that positive 2c, I'm going to subtract. And I have a -12 on this side and a 7c plus 2 on the right. Now I need my constants all on one side and my variables all on the other, and so I'm going to move this 2 over here by subtracting it from both sides. And I am left with 7c equals -14, and we would finish that up by dividing. And so c equals a -2. Letter C. You can see I have variables on both sides again. I need to use inverse operations to get them all on the same side. So I'm going to subtract m from both sides. When I do that, you get 3 minus 1m, which is 2m on the right, and finish up by dividing. Remember, if this is going too fast, just pause the video and catch up. Letter E, I have variables and constants. I need to collect my variables on one side and my constants on the other. So I'm going to move my 5k by subtracting 5k from both sides. That becomes 0, and so it's gone, and you are left with 2k minus 4 equals 16. Finish up by moving my constant over to the other side by adding 4 to both sides. And then divide by 2 to get k equals 10. And again, all these can be checked by substituting your final answer in for the variables in the original problem. It's your turn. I'd like you to try all 6 of these. Pause the video and come back when you're done. Make sure you show your work. Alright, and here we go. We have some things to talk about in this guided practice section. So letter A and B and C and D are pretty straightforward. And then we get to E and F, which kind of seem funny. Now, for E, hopefully you knew you needed to distribute first, but then something special happens. You have an equation or an expression on this side that equals the same thing as an expression over there. And so you need to think a little bit logically, and no matter what x is, say x was 2, if I plug it in here and substitute it in there, I'm going to get the same answer on both sides because they are the same equation. And then if you change that and say x equals 3, well, you're still going to get equivalent equations. So no matter what number you substitute in for x, this will work because this is the same thing as that. And so in that situation, you would say that you have an infinite number of solutions, meaning x can be anything and both sides will remain balanced and equal. Look at number F. That one's different. I simplified both sides and I ended up with a -3a on the left and a -3a plus 1 over here. And this plus 1 is messing everything up. There is no way, say I said a was 2, I'd get a -6 on this side, but I would get a -5 on that side. There's no way that these will ever equal each other because that plus 1 is messing everything up. And so we're going to say that we have no solution. It's kind of logically impossible. You have something on this side, and this side looks like it's the same, but every time I'm adding 1, it's gonna result in no solutions. So just be aware that you can have situations pop up like this. Okay, thanks for watching this video, and as always, you can re-watch this video or come ask questions of any teacher if you have them. Thanks much.